Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be exploring a topic that you oftentimes feature in geometry, but also something that we're going to want to formalize for our understanding of algebra, and that is the equation of a circle. We're going to talk about what a circle is. I'm going to go over some very obvious things about a circle and some vocab terms that we need to know, but then we're going to get into the algebraic breakdown of how do we actually describe the equation that would produce a circular graph. We're going to look at a circle that's centered at the origin as well as centered at a different point that's not at the origin, and we're going to look to see how we can manipulate ways of writing the equation for a circle. Now first we need to talk a little bit about some general information about a circle. What is a circle? Well, a lot of times people might just say, well, I mean, Linford, it's obvious, it's a shape like this. But let's remember the formal definition for a circle. It's a shape that consists of all the points that are a given distance from a center point. So a circle is defined as all the points that are equidistant, that are the same distance away. That's a terrible circle. Let me try that again. There is a shape where the distance between the center and any point on the circle is the same no matter what point you pick. It's always the same distance, okay? So that's the idea of what it means to be a circle. Now, there's a couple vocabulary terms we're going to reference that I feel is probably just good to remind people of. The center of a circle is the middle point that is equidistant from all the other points on the circle. The radius is the distance value between the center and a point on the circle. So we keep saying that a circle is the collection of all the points equidistant by a certain distance from the center. Well, what is that distance? That's what the radius is. Now the diameter, that's where it gets a little trickier. The diameter, it's a distance value, but it's the value of the distance between 2 points on the circle that each lie on a line that passes through the center point. Now, in short terms, the diameter and radius are related to each other because the diameter d, is twice the size of the radius. So it's 2 times the radius. Let's take a look at a diagram and see if we can put all these vocab terms to some pictures. So here's a circle. We have all of the points that are a certain distance away from the center. Now the center of the circle is right here. Let's label that center. It's the thing that's, no matter what other point you have on the circle, it's the same distance away. Now the radius is this distance right here. It's the actual measure of the distance from the center to one of the points. This is the radius. And you know what? Here's another example of the radius. Let me see if I can draw this a little nicer. Radius and radius. So that's the idea of the radius. It's that actual measure from here to here, from here to here. Now, the diameter is a measure of the distance from one point to another on the circle, where if you draw a straight line between them, it also passes through the center. Why is that last part important? Well, sometimes people say, okay, the diameter is the distance between 2 points on the circle. All right, here's a point on the circle. Here's another point. There. Here is an example of the diameter, right? Well, no, that's not the diameter. The diameter has to be the largest distance you can have from point to point on a circle. A way of thinking about that is, okay, if I want the diameter going from one point to another, it needs to pass through the center. So there's the diameter. If you're going to draw a line for if you're going to draw a diameter from a given point, that point needs to be on a line with the center. and you will have the greatest possible distance you can get. So this red line that I just drew and the blue line right here each have the exact same distance. They're both the diameter length for the circle. So, like I said before, the diameter is just twice the radius because there's two radii that make up the diameter. There's two radii back to back. So that's the idea of these different terms that we have. We have the center point, the radius being this measure or this measure, and the diameter being this whole measure right here. Diameter. It's that whole length measure. Now let's talk about how to actually write the equation of a circle so that way we can take our understanding of algebra to produce a circular graph. Now, there's a couple ways of interpreting the equation of a circle, and it really depends on where the center of the circle is. Now we're going to start rather simple, and we're going to say that we're making a circle that's centered at the origin. That means on a graph, it's centered at the point 0, 0. That point right there where the two axes meet, okay? So centered at the origin, 0, 0. Here is the form of the equation that you're going to see. The form of the equation is x squared plus y squared is equal to r squared. Now this is where r is the radius of the circle. R is the measure of the radius of the circle. That's what that value is. So this is the form that our equation will take, okay? It's not in y equals mx plus b, okay? It's not in some linear form. It's not in some quadratic form. It's a closed shape. So that's kind of why we like to have x squared and y squared on the same side here. So we have the two variables on the same side, and all we need to know is what's the radius of the circle. So let's take a look at these two examples right here. You'll notice both of them are centered at the origin. You can check that by just seeing, okay, what's the distance from the origin to one point, and the distance from the origin to another point, etc. You'll see that both of these graphs are centered at the origin. This one, we have a length from 0 to 2 in any direction we look. Any point on the circle is always 2 units away from the origin. So here we can say that the radius of the circle, r, is equal to 2, because we're 2 units away. So if I had to write the equation for a circle, I would say, well, it's x squared plus y squared, and that will be equal to the radius 2 squared. Well, I know what 2 is, or I'm sorry, I know what 2 squared is. That's 4. So this right here is the equation for that circle. That's the algebraic equation that would give me this graph right here. All that we did was just plug in what the radius is and square that value. So let's take a look at this circle here. Again, it's centered at the origin, and the radius looks to be 3. In any direction I go, to get to a point on the circle, I always have to be 3 units away from the origin, or from the center. So here, my radius is 3. So the equation is x squared plus y squared is equal to, well, the radius 3 squared. And 3 squared, I know what that is. That's just 9. So this is the equation for this circle. X squared plus y squared is equal to 9. That's all that we have to do to write the equation for a circle centered at the origin. All you're doing is just saying, well, this is the general form, and you just have to plug in that number. That's it. Now let's take a look at an example where we've shifted the circle on the graph, where we might have made the center not something as nice as the origin. So when you have a circle that's centered at a point that's not the origin, we're going to say that that point, you can represent it by h and k. These are the xy coordinates. We're just not using x and y because we're going to use that in the equation. So I don't want to use multiple x's and multiple y's. I'm just going to use different terms. Now, the equation for a circle that's centered at some point that's not the origin, it's going to look a little different, but we're going to try to connect it to what we did before. So here's the general equation. You have to take x and subtract the x coordinate for the center, and then you square that value. Then you add on the y component, but you have to subtract the y component from the center, and you square that value. And just like before, you set it equal to the radius squared, okay? Again, this h is the x component of center, of your center point. The k here is the y component of your center point. And r here is just the radius. So all that we have to do now is say, well, what's the origin? Plug its x coordinate in here and its y coordinate in there. And then we also have to include what the radius is. So all we have to do is just an extra step. We have to incorporate what the center is. So let's take a look here at this example. We have a circle, and it's centered at this point. That point is 2, 1. So let me write that down. That point is 2, 1. Now, let's think about what the radius is. Well, any point from the center to the circle seems to always be 1 unit away. Can't you see that right there? It always seems to be 1 unit away. So we're going to say that the radius is 1. So radius here is 1, and the center, let me write that a little neater, the center is 2, 1. So let's just plug this information into what we have for the circle. So we have x minus, well, the x component is 2, and we square that, plus y minus, well, the y component of the center is 1, and we square that, and that should be equal to the radius 1 squared. So if I wanted to simplify this, I could say x minus 2 squared plus y minus 1 squared is equal to 1, because 1 squared is just 1. This is the equation for the circle. Notice a couple things here. Notice that I have x minus 2 and y minus 1, even though we had positive 2 and positive 1 here. The equation says subtract the x value, or the x component, subtract the y component. That's why these are negative, okay? I'm literally copying this exact format right here, okay? I'm literally copying it. I'm plugging in, so x minus, and I plug in what the x component is. Y minus, and I plug in what the y component is, okay? So be careful with your signs here. This is a common area where students tend to make mistakes. They mix up signs. They think for some reason they need to change this around. No, 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 no. You can leave x minus there and plug in what the h and the k would be. So this is the idea of how we write the equation of a circle at a point that's at the center point that's not the origin. Now, I want to try to take a minute to connect this format with what we did previously, this format. Notice here, they're very similar. We take x components and square it, y components square it, and we set that equal to the radius squared. Well, this right here is a bit more elaborate. What would happen, though, if we took the center 0, 0, and plugged it into this equation, well, you would get x minus 0 squared plus y minus 0 squared. Oops, square needs to be on the outside. And you set that equal to r squared. Well, isn't x minus 0 just x? And isn't y minus 0 just y? Yes, this is why the two equations are basically the same thing. This is the general form you're always going to see. This is just a simplified form when the origin is 0 and 0. Okay? So try to remember always the general form, because this will tell you how to write an equation no matter where it is on the graph. Let's take another example here, and let's try to pause the video and write the equation for this circle. Give this a try, see what you're able to come up with, see if you can find the radius and the center, and see if you can put that in the appropriate way so that you get what the equation is. Pause the video, take a minute, and then we'll see what you get. All right, well, hopefully you had some time to work through this. Again, we want to make sure we identify what information we need here. So we know that the center of the circle is at -3 and 1, and we know that the radius is 2, because no matter where we go from the center to the other edge of the edge of the circle, we're always 2 units away. So we're going to take this information and we're going to put it into our general form equation, x minus h squared plus y minus k squared is equal to r squared. So let's just start plugging information in. X minus h, well, h here is the x component of our center, so that's -3. So x minus -3 squared plus y minus k, well, k is just the y component, which is 1, so y minus 1 squared, and that's going to equal r squared. Well, r in this case is 2, so we have 2 squared. All that we did, we kept the exact same format to the equation, we just plugged in. What's the x component? What's the y component? What's the radius? And that's it. That's all we had to do. Now we can go ahead and simplify this because, well, we know what 2 squared is. That's 4. So let's just say that's a 4. And notice we have a double negative here. We have x minus -3. Why don't I rewrite that to x plus 3 squared plus y minus 1 squared. Here is something, again, that students tend to make mistakes with. Notice here that I have x plus 3 and y minus 1, but the center point is actually -3 and +1. Signs flip. So be aware of that, okay? That's an important thing to realize. It's because these are negatives. That's what throws things off. So the center is whatever the opposite of this point is and the opposite of this point, okay? It's helpful to just start with the basic equation, just simply plug everything in, and then simplify if you can, okay? That's a helpful technique. Be very careful with your signs and understand that though we have x plus 3 here, it's really -3 for our center. And though I have y minus 1 right here, it's really +1 for the y part of our center. So be aware of the differences in sign, get comfortable with that, try to do some examples, and really try to understand what the equation is telling you about where the circle is located on the graph and really what the size of the circle is. Now let's try an example where we're given different information than we're used to seeing for determining the equation of a circle. In this problem, we need to write the equation of a circle with the center at 4, -1, and a circle that contains the point -3, -2. So write the equation of a circle with the center at this point containing this point. Well, what does that mean? Well, anytime I deal with geometric problems, I like to draw out what's going on. So let me get a little quick sketch of a graph here. And let's see, I need to be at -4, -1. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. So -4, -1 is 4 units this way and 1 unit down. So over here, something like this point would be the center of the circle. Now I need this circle to contain the point -3, -2. So somewhere down here. So how am I going to figure out what the equation of this circle is? It's going to look, not the best drawing. I'm not the best at drawing circles, but it's going to look something like that. But how am I going to find what that circle is? Remember, when I need the equation of the circle, I need to know what the center is. So x minus h squared plus y minus k squared equaling r squared. I need to know what the center is. Well, I know that here, but I also need to know what the radius is. I don't really know what that radius is. I haven't been told in this case what the distance from the center to this point -3, -2 is. So that's going to be the tricky part. I know h and k. I'm told what the center is, but it's finding the radius that'll be difficult. So here's what I want you to do. Pause the video, take a minute, try to recreate this graph on your own, redo this drawing on your own paper, and try to really play around with the placement of these points and think, how can you find this distance here? It's easy to find a horizontal distance or a vertical distance, but we have this angled distance right here. Try to see if you can think, how can we figure out that length? Pause the video, try a couple different diagrams, and let's see what you come up with. All right, well, hopefully you were able to come up with some diagram to see what's going on, and hopefully you were able to find some way of finding the distance between these 2 points. One of the techniques, though, that's most commonly used in trying to find the distance between 2 points on the graph is really thinking about, well, how far over vertically and how far over horizontally are these 2 points from each other? Let me try to draw that out. To go from the black point to the blue point, I have to go over, oops, let me draw that a little neater. I have to go over 1 unit this way, and I have to go 1 unit down. So 1 unit horizontally and 1 unit down. Let me try to zoom out a little more and show what's going on. To go from the center point to this, let's say, blue point being on the circle, I have to go over 1 unit this way and 1 unit that way. These are the horizontal and vertical components. Notice that that forms a right triangle, doesn't it? It forms a right triangle. I know one of the sides and I know the other side. I just need to find the hypotenuse. So how can I go and find that hypotenuse? Well, think back to what we did with right triangles. The Pythagorean theorem related all the sides of a triangle together. So to find this distance right here, we can say, well, the one side squared plus the other side squared is equal to the hypotenuse side squared. I don't know what the hypotenuse is, so I'm labeling it C. That's what I'm trying to find right here, is that length. So 1 squared is 1, 1 squared is 1, and that's equal to C squared. 1 plus 1 is 2, and that's equal to C squared. To get C by itself, we're going to take the square root of both sides. So C is equal to the square root of 2. That is this distance right here. That's the hypotenuse. That's the length between the point that's the center and the point that's on the circle. So let's try to clean this up a little bit. Imagine that you have this circle right here. The distance between any point on the circle and the center is square root 2. Whatever that length is, the square root of 2 is how far away we are from the center to any point. So that's the radius. So, I know I labeled it C here. I'll say the radius is the square root of 2, and the center is -4, -1. So if I have to write the equation for this circle, I would say, well, x minus, what's the x component of the center? -4. And I square that. And then we add y minus, what's the y component of the center? Well, it's -1. We square that, and we set it equal to the radius squared. So I'm very careful with parentheses here and how I substitute all of the information in. X minus -4, I can just rewrite that to x plus 4, can't I? Because of the double negatives. So I have x plus 4 squared for the equation. And then the same thing for the y minus -1. I could just say y plus 1, and I could square that for the equation. Now the last part I could leave as the square root of 2 squared. I could leave it written that way. But let's just go ahead and simplify. What's the square root of 2 times the square root of 2? Well, it's just 2, right? The exponent gets rid of that radical sign. So here is the simplified form of what this equation is. This is an equation of a circle that's centered at -4, -1. Remember, the signs are going to be different, so -4, -1. And it passes through this point. -3, -2 is a point on this circle. How can you know for sure that that's a point on the circle? We did all of this work to get this equation. How can we know for certain that that is a point that's on our circle? Well, hopefully you're saying just go ahead and plug it in. Exactly, just plug it in. So let me do this in green here. We're going to check our work. Instead of saying x plus 4, in this case, x is -3 plus 4 squared, plus y in this case is -2 plus 1, and we're going to square that, and we should get 2, okay? Keep in mind, x and y in the equation, these are where you plug the coordinate points in for any point that's on the circle. It's not where you plug the center in. No, the center gets plugged into the h and the k part, okay? The point on the circle gets plugged into x and y. So make sure you're aware of those differences. So anyways, back to the problem. We have -3 plus 4 is 1. We're going to square that, plus -2 plus 1 is -1. We're going to square that and set it equal to 2. 1 squared is 1. -1 squared is 1. And what do you know? That equals 2. So it works. We have this equation that satisfies this information. We're passing through that, or we have that center, and we're passing through that point. So that's the idea of how we can really use our understanding of right triangles to find distances, and to how to help us find the distance of the radius for a given circle. Now, one of the other more common types of problems you'll see in later math courses, such as college algebra or pre-calculus, or even something you might see on the SAT, is where they ask you to switch between different forms of different equations. So, for example, the general form of a circle is when you take the standard form. Standard form is the x minus h squared plus y minus k squared, and you set that equal to the radius squared. That's the standard form. The general form is when you actually multiply out these binomials and then combine all of the like terms. So what we want to be able to do is switch between representations. Here, for example, is the general form of a circle. Originally, there was some x minus h squared plus some y minus k squared equaling some radius squared. But when they actually multiplied out these binomials and combined any like terms, they got this equation. What we want to do is be able to switch back into this very nice standard form, because the standard form tells us where's the center and how big is the circle. That tells us a lot more information than this does. This doesn't really tell me any information at all. So what we need to do is do some way of rewriting this to where we can take the x's, the x squared plus the 8x, and we can take the y's, the y squared plus the 6y. Well, let me move the 16 over so it's negative 16. I just moved it over to the other side. I subtracted it over. We need to rewrite these so that they're now these binomials again. How can we go ahead and do that? How can we rewrite the x squared plus 8x and the y squared plus 6y so that we have two binomials that are representing the equation? Pause the video, take a couple minutes, think back to the work you've done in other algebra courses and think, how did we go and take an equation that was in this standard form, or I should say that's in this general form, and how did we rewrite it so that it would be represented by the binomials that were there originally? There was a way for undoing that, for kind of reversing this process. See if you can think back to how we get these back into squared values. Take a minute, pause the video, and let's see what you come up with. All right, well, hopefully this was making a bit more sense to you after I said the phrasing. We need to take these and turn them back into squared values. The technique we had for rewriting something from a general form into a squared format is by completing the square. We use the process of completing the square to write something that's all laid out and simplified back into a binomial. So what we're going to do, or I should say by a binomial squared. So what we're going to do is we're going to look at the x's and the y's separately. The very first step I always want you to do when completing the square, especially for multivariables, step one, get the x's together, the y's together, and move the constant term over to the other side. It's just going to keep your work nice and organized. So remember, in completing the square, what we have to do is, okay, we're going to need to add something to these x terms. We're going to have to add a term to this so that we can hopefully factor it down into a binomial. Well, what do we add? We have x squared plus 8x. We're going to take 8, the thing that's attached to the x, we're going to cut it in half, so we're going to divide it by 2, and then we're going to square it. So 8 divided by 2 is 4. 4 squared is 16. That's what we're adding to the x terms. We're adding a 16. Again, it comes from half this number, half whatever's attached to the x, squared. So that's why we get 16. And then what do we do for the y's here? Well, same thing. We have y squared plus 6y, and we're going to add to this whatever 6 divided by 2 is squared. So 6 divided by 2 is 3, and 3 squared is 9. So we're going to go ahead and we're going to add 9 to this setup. So what we've done here is we have the exact same equation as before. However, we've now added 16 and we've added 9. These two equations are no longer the same thing, right? I mean, I should set it equal to negative 16, but they're not the same thing. I've added a 16 here and I've added a 9 here. These are totally different. So to keep it balanced, remember, anytime you manipulate an equation, you have to keep it balanced. So since I added a 16 here, I'm going to add a 16 to the other side. And since I added a 9 here, I'm going to add a 9 to the other side as well. So that's step 2. We've gone and we figured out what we need to add to each of the terms, and we made sure to add both of those things to the other side so we keep the equation balanced. If need be, just cancel out the 16s, cancel out the 9s, and you're right back to where you started, okay? But we're going to see what happens when we leave this in. So this is step 3. X squared plus 8x plus 16. We should be able to factor that down now. Let's see, what times what gets me 16, but what adds together to get me 8? Well, x plus 4 times x plus 4. The 4's multiplied together to give me 16, but they add to give me 8. So I could say I have x plus 4 squared is what this is. Now let's look at the y's. What times what gets me 9, but what added together gets me 6? Well, hopefully you're saying y plus 3 and y plus 3. The 3's multiplied together to give me a 9, but they add together to give me a 6. So all that I can say here is y plus 3 squared is what y squared plus 6y plus 9 factors down to. By completing the square, we guarantee that we get this nice setup of factoring. And then, let's just add these together. Negative 16 plus 16 is, well, that's just 0. It cancels out. And then add 9. I get 9. Here is the equation for this circle. X plus 4 squared plus y plus 3 squared is equal to 9. That and this equation are the exact same thing. They give you the exact same graph. All that we did here was we just rewrote it. We used completing the square to manipulate the equation, to rewrite it. So now I have it in this standard form, and I can tell you right away by just looking at this equation, it is centered at -4, -3. Remember, we take the different signs. So that's the center. And the radius is, well, let's see, it's the square root of 9, so that's 3. So I can get a pretty good picture of what this circle is looking like and what other points might be on this circle by just interpreting the equation. So hopefully this is making sense to you, and hopefully you're understanding how we can represent a circle by the standard equation format. And hopefully you're seeing how we're using the completing the square technique to actually manipulate a general form equation so that it's a nicer, more standard format for us to work with. If you need, go back. I have videos on completing the square. Take a look at that process and let me know if you have any questions or comments or what you thought of the video. As always, my email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.